Lesson 10.8, Special Right Triangles, Part 1. I've split this up into 2 days because this is something that kids usually struggle with, and I particularly remember struggling with it when I was in school. But I think I've found out the hopefully easiest way to figure these out. They just take a little bit of labeling on your picture, and then it makes it way easier. So there's two different types of special right triangles. Right meaning we have a 90, and so we're either going to have where we have a 45, 45, and 90. So that would mean this is a 45 and this is a 45, because that would add to make 90, plus 90 makes our 180. So what that tells me is this is an isosceles triangle where these legs are congruent. And so what we do in that picture is, in this relationship here, the legs, I'm just going to call them L. If I know what L is, I know what the other L is, right? But then the relationship between the leg to the hypotenuse, which remember is always opposite the 90, is going to be that number times a square root of 2. And so I could go through Pythagorean theorem and give you an example, but it's better to just memorize that in a 45, 45, 90, the legs are L, and then the hypotenuse is L times a square root of 2. And then in a 30, 60, 90, we can tell that this is the smaller angle here. This must be our 60, and then this is our 90, because that also adds to make 90 plus 90, 180. So this one's a little trickier. Across from the smallest angle, so across from the 30, is going to be our shortest leg. We call that L. Then the hypotenuse compared to this short leg is always 2 times that, double it. So let's say this leg is 10, that would mean my hypotenuse is 20. So that's an easy relationship. The weird part is the longer leg, which is across from the bigger angle, the 60, is going to be that leg times a square root of 3. So I can just remember the difference between these because I think 45, 45, those two are the same, so I can think radical 2. And then 30, 60, 90, they're multiples of 3, so I think radical 3. But let's just try some. Find the length of side x in simplest radical form with a rational denominator. That means that we cannot have a square root of something in the bottom of our fraction. Okay, so this should have told us, I bet, that this was an isosceles triangle. I think I left that out. So it'll tell you that, hey, this is an isosceles right triangle. And so this, I want you to label, this is L, and this would be L, and this would be L times square root of 2. I know what L is. I know it's 10. So if they would have wanted me to solve for this leg, that would have also been 10. All I have to do is replace L with 10. And so x, or this hypotenuse, would be 10 times square root of 2. They don't want a decimal. They want the radical kept in there. So that would be the answer. All right, number 2, it does have it labeled that these are congruent. So this is my 45, 45, 90 again. I want you to label. So I've got leg, leg, leg square root of 2, because this is my hypotenuse. Again, set them equal. I know what L is. So these are the easier problems. I'm wanting the hypotenuse again. So I'm just going to replace L with square root of 12. But what's happening here is I'm taking a square root of 12 times a square root of 2. You can multiply radicals no matter what's under there. So 12 times 2 would be the square root of 24. But they want it in simplest form. So we've learned how to simplify radicals. I need to know that this really breaks into a square root of 4 times a square root of 6. And square root of 4 is a 2. So I get 2 square roots of 6. So all I did was plugged in L, multiplied, simplified my radical. Okay, two more, just kidding. 2 more of the 45, 45, 90s. And so I see this would be 45, 45, 90. Okay, so these are my legs, L and L. This is leg times square root of 2. This is where it gets trickier because I don't know either leg. So I'm actually like working backwards or making an equation here and solving for L. So if we had L times square root of 2, I would have to get rid of square root of 2 by dividing. This would cancel and give me L. So L equals 7 over square root of 2. But they're not going to like this answer. They do not want a radical in the bottom. So we do what's called rationalizing the denominator, where I multiply by that radical over itself, because secretly this is a 1. So multiplying by a 1 does not change the value. Then I multiply straight across, so I get 7 times square root of 2. And then over, this would be square root of 2 times square root of 2, which is square root of 4, which is actually just 2. Right? Because 2 times 2 makes 4. So whenever I have a number times itself under a radical, it actually just becomes that number. And then you would just make sure you can't reduce 7 over 2, which you can't. So now this is what they're wanting for L. All right, and then number 4, another 45, 45, 90. So these would be my legs. This is leg times square root of 2. You're going to have to make an equation here and solve for the L. So I'm going to divide away square root of 2. I can divide these radicals. So you can multiply and you can divide radicals, even if they're not the same number. 10 divided by 2, that would be square root of 5. Because another way I could write this is one big square root with 10 over 2. 10 over 2 is 5, but it's still under the radical. So that's what the legs are. Okay. Now let's switch to the 30, 60, 90s, a little trickier. Make sure you label. So if you look up above, across from the short leg or across from the 30, that's always your L. So they're the easiest when you are given the short leg. Then all from there is just plugging it in. Okay, we would also need to know that the hypotenuse, so the side across from the 90, is going to be 2 times L. And if we needed to know the long leg or the side across from the 60, this would be leg times the square root of 3. But I don't need to know that. So since you know that L is 2, just replace this L with 2. So it'd be 2 times 2, which is 4. So hypotenuse is 4. All right, number 6. Let's label. So across from my 30, that's my short leg, that's L. So this will be an easier problem since I have the L. Hypotenuse would be here. That would be double that. So this would actually be 12 if they wanted to know. They want this long leg, which is leg times the square root of 3. But since I know L is 6, I'm just going to replace L right here. So x will equal 6 times square root of 3. I don't want to multiply those because 6 is just a regular number, square root of 3 is some decimal. So I'm going to just keep it like this. And that's all on that one. Okay, we've got 2 more on the next page. Number 7 and 8. Okay. 30, this would be your short leg or L. I do not know what L is, so I'm going to have to make an equation and solve that. I know that the hypotenuse is 2 times my short leg. So this has now created an equation where I can divide away the 2 to get L by itself. And so I get that L is square root of 8 over 2. But this is not simplified because square root of 8 actually is square root of 4 times square root of 2. Square root of 4 is 2, so this becomes 2 square roots of 2 divided by 2. And then I can divide 2 by 2, which is just 1. So really I just get square root of 2. And that would be this one, my short leg, because I wanted L. And then one more. So labeling is the secret here. I'll label all the time. Across from the 30 is the short leg, L. Then my hypotenuse, which is 2 times L. And then this is the hardest because they're only giving me the long leg, which is equal to the leg times square root of 3. So I actually have to use this to solve for L. I would divide by square root of 3. I can divide square roots. That'd be square root of 2 is what L is. But I didn't want the short leg. They actually want me to take it a step further and find the hypotenuse, which is 2 times square root of 2. You're just replacing L with square root of 2, which is the answer.